and welcome. I am Dr. Pauline Fu. In this lab, I will introduce business analytics in Excel. Specifically, I will do an example. Block Club sells print jerseys as one of the product offerings and considering purchasing printing equipment. Two vendors have proposals. The fixed cost is $25,000 for proposal A and $32,000 for proposal B. The variable cost is $12 for A, $10 for B. The revenue generated by each unit is $20. So this is a business problem, and we are going to answer some questions using Excel. Question 1, if the expected volume is 3,000, which alternative should be chosen? Question 2, if expected value is 3,500 units, which alternative should be taken? Question 3, what is the break-even point in units for proposal A? Question 4, what is the break-even point in units for proposal B, etc.? Okay, so this is a business problem. There are some questions. We are going to set up a spreadsheet to answer the question. So first, we are going to set up a spreadsheet like this. Okay, you can set up different way. This is just one way of set up the data. Okay. And we put in some given numbers. Okay, try to use two screens. Okay. So the selling price for both proposals are $20, $20. The fixed cost for proposal A, $25,000. Fixed cost, $32,000. Variable cost, $12 for A. Variable cost for proposal B, $10. Okay, so question A asks you if the volume is 3,000, which proposal would you choose? Okay, so our decision is based on the profit. Which proposal will give us more profit? We'll choose that proposal. Okay, and the profit equal to revenue minus cost. So we need to calculate total revenue first. So total revenue, just try to increase font. Okay. Total revenue for proposal A, revenue equal to unit price, selling price, times number of units. Okay, number of units, suppose it is 3,000. So we type in 3,000 here. Oh, that is the number of units. So we input 3,000. Okay. Total revenue is here equal to selling price times number of units. That is total revenue. Fixed cost, we just copied the number here. Total variable cost equal to number of units multiply variable cost per unit. So equal to number of unit times variable cost per unit. Okay. So total cost, it is just these two numbers add, So total cost is a fixed cost plus variable cost. Okay, so equal sum of these two numbers added together. So this is total cost. Now profit equal to revenue minus profit, total cost. Revenue minus cost is profit. So I'll redo this formula. So equal revenue minus cost. So the number indicate it is a negative number because it is using the bracket, indicate it is a negative number, means you'll lose $1,000. So we calculated proposal A when you have 3,000 units. Similarly, we can calculate proposal B. Okay, so I'm just trying to use the left alignment. Okay, so total number of units, again, 3,000. Revenue equal to number of units times sale price. Okay. Fixed cost, which is 32,000. Variable cost equal to number of units times variable cost per unit. So total cost, it is these two numbers are together. These two, 32 plus 30. Profit equal to revenue minus cost. Okay. I will double check this number to see. 32, 10, 20, 32, 10, 20, that's correct. So total revenue, fixed cost, variable cost. Yeah, that's right. So the profit is negative 2,000 for proposal B. If you produce 3,000, proposal B will have a negative profit, means we'll lose money 2,000. Proposal A lose money 1,000. So if you are asked to choose between proposal A and B, you choose proposal A, it lose less money. So that is the question A we answered. Question A, we should choose proposal A. Question B, if the expected value is 3,500 units, which alternative should be taken? So basically you go exactly the same procedure. Because we are using Excel, we are going to utilize the beauty of the Excel is that when you change the number, the related calculation automatically be updated. So here, instead of 3,000, I'll change to 35,000. Okay, 35,000. See, all the number automatically updated. Same thing here. Change 3,000 to 35,000. See, all the number is automatically updated. Okay, so for proposal A, if you have number of units 3,500, the profit 3,000. For proposal B, the profit is also 3,000. So you can choose either proposal A or proposal B. They are going to have same profit. In this situation, you may want to consider other factors. Okay. So this is question B. Okay, which alternative should be taken? There is indifference. You can choose either proposal A or proposal B. Now, question C, what is the break-even point in units for proposal A? And what is the break-even point for proposal B? Break-even point means it is the point where revenue equal to cost. So how many units should be produced so that revenue equal to cost? That is question, okay? I'm going to combine question C and question D, okay? together. Okay, combine these two questions with this is a break-even point. So I'm going to use trial and error. Okay, I may want to start 100. So this is number of units. So again, it is for proposal A. Okay, all this column for proposal A. So suppose number of units is 100, 200, etc. Okay, until I see number of unit is 4,500. Okay. So the reason is I want to also combine this question here. So read question here. What is the profit for proposal A and proposal B for the expected volume 100 units to 4,500 units? So I'm going to combine those three questions together. Okay. So that's why I produce the units from 100 to 4,500 units. Okay. So if the number of units is 100, the question is what is the proposal A profit? That is the question I need to answer. Okay, that is the question. So I'm going to use absolute and mixed cell references as well as the relative cell references. Okay, so what is the profit? Profit equal to revenue minus cost. Revenue equal to number of unit 100 times selling price. Okay, that is the revenue. Okay. Revenue minus cost. Cost has two parts. One is fixed cost. Okay. And the other is, our typing formula here, the other is variable cost, means number of unit. In this case, I use cell reference. Okay. Number of unit times variable cost per unit. Okay, so this is the formula. Keep in mind, this formula is true only for when the unit is 100. If you want to apply the formula also to unit is 200, 300, etc., you need to modify this formula. How? So B27 is this one here. So this time it's 100. Next time, we hope it will be 200. So 200 is in cell B28. So 27 becomes 28. But the column B is fixed. Something is fixed, you use dollar sign. So instead of B27, you say $B27, means column B is fixed. Row 27 will become row 28 in next calculation and will become row 29 in the next after. Okay, so this is B27. And C8, this number is a selling price. It is a fixed number. So we are going to use $C, $8. This number is fixed. Okay. And now C9 is fixed cost. This number is also fixed for regardless how many units. Fixed cost is the same. So $C, $9, and then B27. Again, I need to fix column B, and I call $B27 is a mixed cell reference. Okay. Last one is a C10. C10 is a variable cost per unit, is a fixed number. So it is $C, $10. Okay, so this formula, after I do the multiplication, it would be, you can copy down formula later. Okay, so I press Enter key. So this is for when number of units is 100, you lose money, the profit is negative. So how about when number of units is 200, you just copy down the formula, okay? You just put your mouse on bottom right corner until you see fair handout, double click, okay? And you get all the numbers for different number of units, okay? And so this, we did proposal A. Similarly, you can do proposal B, okay? So for proposal B, I will type in some headings, number of units, and proposal B profit. Proposal B profit. So again, I will start with 100, 200, then I use fair handle to copy down until I see 4,500 here. Now, by the similar method, you calculate the profit for proposal B, okay, typing equal, okay. Profit equal to revenue minus cost. Revenue equal to number of units times selling price per unit, okay. And then minus cost. Cost equal to fixed cost plus variable cost. Variable cost equal to number of units times variable cost per unit. Okay. So again, I need to modify the formula. Okay. So I need to fix, modify here. So it is $E27. F8, I need to say $F, $8. So $F, $8. And for F9, F9 is fixed cost. So it is $F, $9. $F, $9. And E27, I need to fix column E. F10, F10 is a variable cost per unit. That is a fixed number for all the different units. So it is $F, $10. Okay, I'll double check. So, okay, press Enter. And now, put your mouse on the bottom right corner until you see fair handle. This is fair handle. Okay, this is not. This is not fair handle. This is fair handle. So double click. Oops. And you get calculation for profit for corresponding to different number of units. Okay, so we finished this one. Now let's answer the question. So question C, what is break-even point for proposal A? What is break-even point for proposal B? For question G, we already answered. So the question is, what is the profit for proposal A and B? When the number of units from 100 changed to 45,000, we already answered that. Okay, so this is the profit here for question G. So now we just focus on what is the break-even point for proposal A. Okay, break-even means when you have revenue equal to cost, means revenue, profit equal to 0. When profit equal to 0, that is break-even point. See here, proposal B, when the unit is 32,000, profit equal to 0 means revenue equal to cost. So this is the break-even point, 32 units. But here we do not have 0, okay? But we can see from this number, when you have 3,100, you get negative profit. When you have 3,200, you get a positive profit, okay? Mathematically, there must be a point where 0 happened between negative 200 and 600. There must be a point. Our task is to use Excel to find that point. Okay, to find that point. So how do I find that point? Well, there are many methods. This is one this is my method. I haven't found elsewhere. Okay, just found the 0 point between negative 200 and 600. So how? So I'm just going to explore. So you select this data range and you move this down. When your mouse becomes a hand, you can move it down. You can move it down. Okay. And now you increase by 10 units. So from 3,100 to 3,110. And then 3,120, etc. Okay, so you keep on going. Copy down. See, there is a point 0 happened here. Okay, there is a point 0 happened here. Oops. Okay, so we found this point. So maybe we put the answer here. So for this one, the answer is 3,125. 3,125. And for this one, we have 3,200, the answer, 3,200. And for question A, we see proposal A. Question B, either A or B. They are indifferent because they have the same profit, okay? All right, and question E and F. What is the break-even point in dollars for proposal A? In dollars, break-even point in dollars for proposal A. What is break-even point? In dollars means what is the, this is in dollars. What is the break-even point in dollars? So the question should be clear. What is the break-even point in profit, maybe? So in dollars, it is 0. Okay. Same thing here. In dollars, it is 0. The profit is 0. That is definition of break-even point. When profit equal to 0, that is break-even point. Unless the question asks you, at break-even point, what is the revenue or what is the cost? You can do the separate calculation, okay? Or you can here, plug in, remember we have this model here, plug in dollar value here, plug in here, 3125 here, 3125. See, those are the dollar value at break-even point. Revenue is this dollar, total cost is this dollar, okay? Same thing here. If you plug in 3,200, the break-even point, you get revenue 64, total cost 64. Those are in dollar value, okay? So maybe I'll write down here. So for proposal A, 62,500. Okay, that is for profit or for cost. And for proposal B, 64,000. All right. So we answered all the questions. Okay. Sometimes you may want to create a graph to represent the situation, number of units produced versus profit. So in this case, I'm going to produce graph, okay? So to produce graph, I will resume the data to original, so from 31, then 32. So I'm going to delete this one, 31, because I'm going to create a graph. Okay. Maybe the other way I can copy this down, then create a graph. So I'm going to copy, Control C. And then copy to another location, Control V. Oh, I cannot control. When I paste, I only paste special, only paste numbers. I'll try. So only paste numbers. Okay, so now I'm going to delete the one from here to 3,200 here. So I'm going to delete. And then I'm going to move this up. So maybe I'll recopy it. Recopy it here. No. I have to select more. 31, then. Okay, so then I cut this one here. All right, so I'm going to create graph lastly, okay, based on number of units. Okay, based on number of units. This graph will show profit A profit, proposal B profit in one graph. Okay, so how do I do that? Select number of units, select these two columns. Okay, and use I use Mark Command K, Control if you're using PC. Okay, then select this column. Okay, after that you click Insert, recommended chart. Okay, maybe this one. See, you have this beautiful chart showing the profit versus unit. Okay, and use your scales in Excel. You can, for example, change the title. Okay, profit versus unit. Okay, so And you can format this graph as you wish, but the format graph is not the focus of this lab. The focus of this lab is to do the break-even analysis. Okay. So in summary, in this lab, we set up an Excel answered business analytics questions. Okay. Imagine without Excel, especially the last question, how would you to do it? Even with the calculator, without Excel, it is unbelievable. Okay. So anyway, hope you learned something in this Excel. Make sure you also do your work and keep a copy of all your files on OneDrive. Okay. Thank you so much. I look forward to see you next time.